So let's begin our journey into the control section. The best way to understand this section is to start off with an actual example. So we're going to look at the add instruction. So let's get to it. We're interested in finding out what's inside this control section. So what is it the control section does? Well, one of its main functions is to move information from one point in the CPU to some other point in the CPU. Now we've seen before that in order to write information into one of the memory locations here or into the RAM, then the set pin must go high. So when the set pin goes high, we can write information into a memory location. Whenever the enable pin goes high, we can read information out of a memory location or out of the RAM and place it onto the bus. So the set is to write and the enable is to read. We set information into the memory location and we read information out of the memory location. So in order to shift information about the CPU, this control section has to control all of the sets and enables. So when we looked at the clock section, we've seen that the clock enable had to fully encompass the clock set, because what happens is that whenever the clock enable goes high, we place information onto the bus. That is, we read information from a memory location onto the bus. And then whenever the clock set goes high, we set that information, that is, we write that information into a particular memory location. And when the set goes low, that's that information written into the memory location. And then the enable goes low, and it allows this process to then continue again. But also remember from the clock video that it actually takes 4 clock pulses from the master clock in order to go through this one cycle of the clock enable and clock set. And you'll see that whenever we go on and look at it in Logisim. So the best way to understand the control section is to work through a full example. So the example we're going to work through is the add instruction. So we're going to add 2 numbers together. So we're going to have a number in R1. So the number we're going to have is number 4. So that's the binary for the number 4. So it goes 1, 2, 4. And we're going to have a 3 in register R0. So that's the binary for 3. We're going to add both of them together, and we're going to put the result into register R3, and the result is 7, and that's the binary for 7. So it's 1 plus 2 plus 4, which is 7. So the method that work through, and we're going to work through this another twice through this video, okay, so you'll really get to understand it. So the method that we're going to use is, first of all, we're going to put R1 onto the bus. So we have to have the enable go high. It will put this value here, which is 4, onto the bus. And then the temp is going to set, so it will set that number in this temp register. The temp goes low, and that's it held within this point here. We're then going to have to go back and we'll enable the R0. So then we put the number 3 onto the bus. This number 3 will just come straight down into this point here. So we'll have a 4 and a 3 here. The opcode here is going to be 000, which is just the addition. So it's going to take these 2 numbers and it's going to add them together. And that's going to just sit at this point here. And then we're going to have to go and set the accumulator, so that the addition, which is the number 7, gets placed in the accumulator. So the set goes high and then it goes low, and that's it fixed there. And then we've got to put the enable's got to go high in order to put that number 7 onto the bus, and the number 7 goes onto the bus. And then we come along here and we've got to put the set high on R3, so that number 7 gets read in here. And then the set goes low, so that number 7 is held within this register. And then finally the enable goes low, and that's us worked through our full process of adding 2 numbers. So let's go ahead and we'll see how this works in Logisim. So if you go to the resources section, there's a file called add instruction, so you can go and open that up, and then you can come down to CPU, open that up, and you have this circuit here. So what you can do is we right click in the control section, and we'll have a look and see what this control section looks like. So don't worry about it if you don't understand it right away. We'll be working through quite a few of these over the next few videos. So here is the control section, and I think what we'll do is we'll talk our way through it, and then we'll see it working, and it'll give you a good indication of what's happening here. So we have all of our enables. So we've taken all of our outputs here for our enables and we put them at one side. So we've got an enable for the RAM and the accumulator, and for each of the registers R0 to R3. And then we've taken all of the outputs here for our sets. So we've got the memory address register set, accumulator set, the RAM set, the temp register set, and the R0, 1, 2, 3 and 4. So all we've done is just split up all of our enables and all of our sets and put one at one side and put one at the other. Now we've got this thing up here and it's called a stepper. So it's really a counter, and we'll go through that in the next video and we'll show you how we designed this stepper. But for the moment, all we're interested in is what it does. So this is our master clock coming in here. So we can put it in simulation mode, and we can count along. Now as this clock pulses from a high to a low, it goes from 1 to 2, and again it goes from a high to a low, it goes to 3. So all this does is just count along each of the positions here, 5, 6, and now when it gets to 7, it goes back to the beginning again. So that's it back to 1. So this is just a simple counter, or as it's called here, a stepper. So you can see here that the clock enable comes down on the enable side and connects to all of these AND gates, and the clock set comes down and connects to all of the AND gates in the set side. So let's see what happens whenever we work our way along this stepper. So when it goes low, it goes to the next one, it goes to 2, and it's going to 3. Now let's see what happens when it goes to 4. So when it goes to 4, we can see here that this enable side into this AND gate at R1 goes high, and also the set here in the temp goes high. And this is the first part of our addition of two numbers. We want to put the value from our register R1 out onto the bus. So that is, we enable R1 onto the bus, and once it's on the bus we want to set that value in the temp register. But this won't happen until the clock enable and the clock set comes along, and we know what happens is the clock enable must go high first of all. So when the clock enable goes high, we see that this is output onto the enable line. So it means that we are enabling register 1 R1 onto the bus. So that information goes onto the bus, and then what happens is the set's going to go high, and you can see when the set goes high, this temp is going to go high. So it means that we've now taken the information that's on the bus and we've written it into the temp register. And of course the clock set will go low again, and that's it held within that temp register, and then the enable will go low again, and we're in a position to continue on with the next step. So when we go to the next step here, the clock's going to go high and low. So now we go on to step number 5, and you can see in this step here what's going to happen is the register R0 is going to be enabled. So we take the information from R0 and we put it onto the bus, and we also set the accumulator so that the information out of the ALU is stored in the accumulator. But those things won't happen again until we went through the enable and set cycle for the clock. So what happens is the clock goes high and we have our R0s enabled, and after the clock's gone high we can then clock set can go high, so the accumulator is now set. When we clock set goes low, that's saved in the accumulator, and then the clock enable can go low. And we're back to the next step, so we can go on now to step number 6. So go on to step number 6, and you can see here there's another couple of things happened. We have now added the two numbers together. The output was in the accumulator, so we've now enabled the accumulator, so all the result from the addition has now gone from the accumulator onto the bus. And then we're going to place that information into register R3, so it means that register R3 will then be set, but of course these won't happen until we go through the set and enable for the clock pulses. So the enable goes high, and the accumulator is enabled, and then the set goes high, and register R3 is set, so we take the information on the bus and put it into R3. The set goes low, so it's stored in R3, and then the enable goes low, and that's us finished. And that's us finished our entire addition. So if we were to go on the next clock pulse, it would go back to 1 again, and we could continue doing this. So that there shows us how the control section is able to add two numbers together. But what we want to be able to do now is we'll go on to the top level, and we'll work through the simulation on the top level. So head back up to the top level by clicking on CPU. So this is us back on to the top level design. Now you can see what we've done here. If I can zoom in a bit closer here. What I've done is I've disconnected the input to this register so that we can manually put a number in. I've disconnected input to this register so we can manually put a number in. So what we're going to do is we're going to take this number here from this register, put it on the bus, and then it will get into temp, and it will just sit there. And then what we'll do is we'll take this number here, we'll put this number on the bus, and it will just work its way down to point A. So now both numbers will be sitting here, the A and the B, and the addition will have occurred because what we've done is we've set the opcode here to 000, which is in the addition mode for the ALU, so it'll automatically add those two numbers together, and the output will sit here. And then what's going to happen is the accumulator is going to be enabled onto the bus, and the information is going to come along, and it's going to drop into this register here because we'll set this register here, and we'll see the output here. We've disconnected this output so you can just see it coming into this section here. So that's our route that we're going to go through, and that's what we've just seen in the control section. So let's go ahead and we'll do that just now. So let's start off by putting our numbers into the register. So if we were to put the number 4 into this register, so remember it's binary, so that's 1, 2, 4, 8, 16, 32, 64, 128. So that's number going to be 1, 2, 4 in there. And let's say we put the number 3 into this register, then we'll have 4 plus 3, which is 7, will go into this register here. So let's start with our clock pulses. Now it takes 4 of these clock pulses here, which is the master clock, in order to work through the enable set process. So there's nothing going to happen for the first 12 clock pulses because we come down in here, these aren't connected, these 3 here, so it takes 4 clock pulses to go through this one to that one to that one. So it doesn't, nothing happens until the 12th clock pulse. So let's go back up to the top and we'll have a look at that. So if I pulse this 12 times, 1, 2, right, okay. Now on the 12th clock pulse, you'll see now that what's happened is we've taken this value 1, 1. You can see the enable has gone high in this register R0, and it's placed that value onto the bus. So the least significant bit and the next significant bit have both gone high, and you can see that in the control section. So if we can down here, you can see that we've worked our way along, we've got to point 4, and at point 4 here you can see that the R1 has now gone, enable has now gone live, because this point here is live and the enable clock has gone live, so we've got a 1 there. But there's nothing going to happen at the set over here in the set section for this temp register until the clock set goes high. So let's make this clock set go high. If you go to CPU, and whenever you click this again, you'll see the set then goes high. So now the set's gone high, and you can see that the set this temp register here. So it's taken the information here that's on the bus and it's placed it into the temp register. Of course, temp register just goes all the way down and it's just sitting here. So if you click on that, you'll see, maybe possibly see it's actually a value of 3. So we've got 3 sitting there. Now what we want to do is go ahead on to the next clock pulse. So we click on, the set goes low, enable goes low, and now we're ready for the next clock pulse. So the enable will go high. When that enable goes high, you see we're on position number 5 here, and you can see that we've got the R1 has now, R0 has now gone, enable has now gone high, and the accumulator there is sitting waiting for this clock to go high. So let's go ahead and we'll have a look at that. So the R0 enable, that one there, has now gone high. It's placed this value here, which is 124, so that's 4 onto the bus, and that value just comes down and it comes into here. So we've now got 4 sitting there, and we've got a value of our 3 sitting there, and we've already chosen the opcode as 000, so it's already an addition, so it's already worked through the addition, and you'll see that the value sitting there is 4 plus 3, which is 7. But there's nothing going to happen with that. It's not going to get into the accumulator until we set the accumulator, so we can do that with the next clock pulse. So whenever the set goes high, you see here, the accumulator now has been set, so we've now got that information number 7 in the accumulator. So now we're ready to go on to the next step, which is step 6. So again, the set goes low, so that's information stored in the accumulator, and the enable goes low, and then the next clock pulse, the enable is going to go high. So what's happened now is we've enabled the accumulator onto the bus, so we've taken the number 7 and we've put it on the bus. So we've got 1, 2 and 4, which is 7, so that in the sum 7 has gone onto the bus, and when you see in the control section, you can see that the accumulator has been enabled. And what we're going to do next is we've got to enable, we've got to have the clock set has to go high, and this will set the information into R3. So in the next clock pulse, this will go high and we'll get our output to the set of R3. So let's go ahead and we'll do that just now. So here's the next clock pulse here, and you can see that the value of the set has now gone high on register R3, and it's taken the information here from this bus and it's placed it into reg R3, and there's the answer, 7 now sitting in that register. So that's us went through the whole process of adding 2 numbers together, and we've seen how it happens within this control unit. But of course, we're still to have a look inside here, which is the stepper or the counter, but I'll get onto that in the next video. So let's just finish this off here. If we were to go on to the next clock pulse, the set goes low. That means the information is now stored in this register here, and the whole thing goes low again. Now we go on and we've gone back to, we went to point 6 to point 7, it's went all the way back to 1 again, and now we're ready to start the whole process over again. So quite nifty, and it's best just seen via this example, and you can sit and mess about with this yourself, put different values into the registers and see what you can come up with. Now also, you can note here that this is hardwired. Okay, so it's a hardwired function. Now if we wanted it to do some other thing other than add, we would have to change these wires and put them in different positions and put them into different points here. But we can see that by hardwiring this here, we're able to control the flow of information round about the CPU using this setup for the control section. So that's all we have for this video. On the next video we'll go on and we'll have a look inside the stepper. So let's have a quick look just now. So that's the stepper there. So we'll go over that in the next video. So thank you for listening and goodbye.